Hi everyone. Today's lesson is going to be on solving systems of equations by substitution. If you guys can go ahead and find those notes in your binder and grab those. On the top there we have 4 warm-up problems, and then on the left it says solving systems by substitution. Okay, so go ahead and grab those. All right, we're going to get started. We're not going to do the warm-ups. Solving equations, we've done so many of those. I think we're going to skip the warm-up for now. Let's just go right into the definition for solving systems by substitution. If you want to write this down, you should have a method of solving systems of equations by substituting one equation into another. Okay, and there are 5 steps to solve a system of equations, and they're listed here for you. If I highlight those right here, these 5 steps. So if you ever get stuck or lost, just go back to those notes and follow those steps, okay? All right, so up until now, we have solved systems of equations by graphing. And you graphed both lines, and you would see where they would intersect. The intersection point is the solution to those 2 equations. Or maybe you graph the lines and you got parallel lines. Since parallel lines never intersect, that would be a no solution. Or the third option would be they end up being the same exact line twice. So it's like one line on top of the other, and they always intersect. So that would be an all solution or an infinity. Okay, so now we're going to learn a second method to solve these systems of equations, and we're going to do that algebraically. We're not going to graph these. Okay, so we're going to start with the first example. And basically step 1 says look for an equation that is solved for x or y. Well, number 1, both equations are already solved for y. So what we're going to use is a version of substitution method called the equal values method. And the equal values method means when both equations are solved for y, or the same variable, you can set them both equal to each other. So what we can do is we can take the value of y on the first equation, y equals x minus 9, just take the x minus 9 right there, and then set it equal to the value of y in the second equation, which is 4x minus 24. Okay, since both of those are equal to y, we set them both equal to each other. Now you can see all we have is a variable of x that is left, and that's what we need to solve for. Okay, so we're going to use our equation solving skills and go ahead and solve for x. I'm going to subtract x to the right. And then I'm going to add 24 back to the left. Because remember, we need to get x's by itself. So negative 9 plus 24 is a positive 15. Oops, didn't write that very well. And now we need to divide by 3. Those cancel out, and I get x equals 15 divided by 3, which is 5. Okay, now when you have a system of equation, you have 2 variables. You have to find that ordered pair that makes both of those equations true. So what we're going to do is we're going to take this 5 and we're going to plug it back in to one of the original equations. So if I go back here to these equations, I'm going to take that 5 and I'm going to plug it into, I'll just plug it into this top one right here, y equals x minus 9. So when I do that, I get y equals x is 5, 5 minus 9. So y equals 5 minus 9 is negative 4. So now I have my x, I have my y. I'm going to put it in the form of an ordered pair. So it would be 5, comma, negative 4. And that would be my final answer. That's where they intersect if I were to graph those lines. Okay? All right, let me make this a little bit bigger on the second one. We're going to do one more example like that. They're both set equal to y, so I'm going to set them equal to each other. I'm going to start with this first equation here. Y equals negative 8x plus 14. So I take the negative 8x plus 14 and set it equal to the other y, which is negative 5x plus 11. Now, all I have left is x's. I'm going to use equations to solve for x. So I think what I'll do is I'll add 5x to the left. Bring down everything else. And subtract 14 to the right. Excuse me. I get negative 3x equals 11 minus 14 is negative 3. I'm going to divide both sides by that coefficient of negative 3. Those cancel out, and I'm left with negative 3 divided by negative 3 is a positive 1. Okay? Now, what I'm going to do is I'm going to take this value of x and plug it back in to one of these original equations. It doesn't matter which one. You could use either one. I think... Sorry, that was my phone. Ignore that. I think I'm going to plug it into the first equation. So I'll do negative 8 times 1, because that's x, plus 14. So I get negative 8 plus 14, which is 6. So y equals 6. Now I put that in the form of an ordered pair. And my final answer is 1, 6. And that's my final answer. Okay, so if I graph those two lines on a graph, they would intersect at this ordered pair here. That is their solution. Okay, very good. If at any time I'm going too fast, just stop the video and then come back to it. Make sure you're writing all this information down. Okay, number 3 is going to be a little bit different. And number 3 is a little bit different because if you look at the two equations, both of them are not set equal to y, but one of them is. And as long as you have one of them set equal to a variable, you can use that value and plug it into y of the other equation. We're going to be substituting. So what you're going to do here, find your equation for y equals, and I want you to circle that amount, circle that amount, and draw an arrow to the y of the other equation. Now, what we're going to do is we're going to take this value of y and we're going to substitute it into y. Oops, let me get that back here. And I want a highlighter. We're going to substitute it in for y right here, if I can put that in there, of the other equation. So what I do is I write that first equation down up until I get to the y. Now, I'm going to take that value of y, take that y out of there, and in its place, I'm going to put negative 2x minus 8, because that is also y. See here, if I highlight that, there's a y there. So if the value of y is negative 2x plus 8, negative 2x minus 8, I can put that into the y of the other equation. Now, it is 4 times y, so that's going to bring up the distributive property, because we got to multiply. So I'm going to do 4 times negative 2x minus 8, and then finish up that first equation, equals 7. So if you see, if I highlight that y in yellow, all I did was replace that y with the value of y in the other equation. And because it's 4 times y, that's why we have distributive property, 4 times negative 2x minus 8. Now, I just distribute, combine like terms, and solve. So we'll start here with negative 5x. 4 times negative 2x is negative 8x. And 4 times negative 8 is negative 32, equals 7. Combine like terms. Negative 5x minus 8x is negative 13x. Bring down the rest. And now we're ready to solve for x. So I'm going to add 32 to the right. to get 39. And then divide out our coefficient of negative 13. Those cancel out, and I get x equals negative, because a positive divided by a negative is a negative, 3. Okay, now that I know x is equal to negative 3, I can take that value of x and plug it into x of either of the other equations. I would pick the one that's set to y equals because it's going to be easier. So I'm going to take that second equation and do y equals, take out the x, put negative 3 in its place, and just work that out. Negative 2 times negative 3 is a positive 6, just using order of operations. 6 minus 8 is negative 2. Now I have my x and my y, and I put my answer in the form of an ordered pair. Negative 3, negative 2. And that's my final answer. Okay, so that's a little bit new. They're not both set equal to y, so you can't set them equal to each other. We're actually going to substitute. Okay, let's do number 5. Number 5, if you look at those two equations again, you see that one of them is set equal to y, but the other one is not. So I want you to circle the value of y and draw an arrow to the y of the other equation, because that's where we're going to put it in. Okay, so I rewrite that other equation as 3x minus 5. Now I'm going to multiply that by the value of y. The value of y is negative 4, so I'm going to write that in. Write down everything else. Now we're ready to solve for x. Let's work this out. 3x negative 5 times negative 4 is a positive 20. Oops. Subtract 20 to the other side. And then last step is always divide out that coefficient. So x equals 3 divided by 3, which is 1. Okay, now I found x, and look, let's go back to these two equations. Normally I would plug the value of x back in to find y, but they already told us what y is. Y is negative 4. They gave us half the answer already. So our final answer is x is 1, y is negative 4. And that's your final ordered pair. Okay. All right, let's do one kind of similar to that. Let's look at number 7. This time we have two equations, but one of them is set equal to x, and that's okay. We can use that. Since we know the value of x, I'm going to circle that and plug it into x of the other equation. Not y this time, but x. Okay, so I'm going to rewrite that first equation as 4 times x, which is negative 3, minus 9y equals negative 48. Do your multiplication. 4 times negative 3 is negative 12. Copy down the rest. And now we solve. I want to get my y on the left and my numbers on the right. So I'm going to add 12 to both sides. And we get negative 9y equals negative 48 plus 12 is negative 36. Finally, divide both sides by that coefficient. And we get y equals negative 36 divided by negative 9 is a positive 4. So we know y. If we come back over here to our equations, I see that x equals negative 3. They already told us that. So that means they gave us half the answer already. We just need to put it into an ordered pair. So x is negative 3, and we found y is 4. And that's your final answer. Okay? If we plug that into both equations, it would make both equations true. So that would be where they would intersect on a coordinate plane. Okay, we're going to do 2 more together because these will come up with a little bit of a different answer. So let's start with number 8. What are our 2 equations? Negative x minus y equals 1, or y equals negative x plus 4. I want to find the equation where it's set equal to x or y. So that would be this equation right here. Okay, I'm going to switch out colors. We're going to take that value of y, because y equals that, and plug it into y of the other equation. Okay, so we're going to write that first equation down. So I have negative x minus the value of y. Well, y is negative x plus 4, so I need to put that in parentheses because I'm subtracting that whole thing. Equals 1. Okay, so as you can see, the value of y in yellow here is now transferred to the value of y here in that equation. Now we just need to clean it up. So we have negative x. A negative times a negative is a positive x. And a negative times a positive 4 is a negative 4. Let's combine like terms. Negative x plus positive x, well, those are opposites of each other. They cancel out. So all I have left is negative 4 equals 1. Well, when does negative 4 equal 1? Never. Those don't equal each other. So remember, when your variables cancel out but your numbers don't, that's a no solution. And what does a no solution look like on a graph? Well, they make parallel lines. Okay. And let's do one more together. We have y equals x minus 8 and 2x minus 2y equals 16. So I want to find the equation that is set equal to one of the variables, which will be that one. I'm going to take the value of y and plug it into y of the other equation. And it's being multiplied by negative 2, so I got to set that up. 2x minus 2 times the value of y, which is x minus 8. So remember, in yellow, that matches this yellow right here. That's where that comes from. And then finish up that equation with equals 16. Now I'm going to distribute. Negative 2 times x. And negative 2 times negative 8 is a positive 16. Okay, combine like terms. 2x minus 2x, well, those cancel out. And I'm left with 16 equals 16. Well, when does 16 equal 16? Always. Okay, that means our variables canceled out. Our numbers are the exact same. That's an example of an infinite solution. That's an all solution. So if you were to graph that, you would come up with the same line. Okay, so those go together, same line. All right, and that is your lesson for today. This one can be a little tricky, so we're going to keep practicing it. But make sure you always go back to these steps here. These steps are super important. It tells you what to do. You always look for an equation that is solved for x or y. Substitute the expression into the other equation for that variable. Now you're just going to solve it like you normally would. Then go back in and find the other variable and write your answer as an ordered pair. Okay? All right, I hope this lesson made sense. I will also be attaching some extra help videos just in case you need it. Your job now is to complete the homework that goes along with this section. This one, I believe, is, let me scroll down here. Not that one. Okay, so you want homework 2, solving systems by substitution day 1, and I'm only going to have you do the ones on the front, 1 through 6. Okay, just 1 through 6. So if you look at your homework, you're going to use the equal values method for 1, 2, 3, and 4 because they're all set equal to y. But then on 5 and 6, change color up on that one, you're going to do substitution. The value of y, the value of y. Plug that into the value of y in the other equation. Always go back to your notes and take a look at your notes. There's always one that's very similar to it on your note page that will help you work through these problems. Okay, hope you guys have a good day, and I'll see you soon. Bye.